Hello everyone, and welcome to Everything You Need to Know of Minitab in 50 minutes, just in time for that new job, presented by Kusum. So, this is going to be a longer video than we're used to. It will include every single thing you need to know to be successful in that brand new quality engineering or that brand new manufacturing engineering job. So, if you just need special data or information, you're more than free to follow the links on the descriptions. They will link you over to the exact portion where we talk about regression analysis, where we talk about graphs, where we talk about hypothesis testing, DOEs, ANOVAs. Every single thing you've always wanted to know about Minitab will be included on this video in 50 minutes or less. If you want to follow through completely, you're more than free to do it, or if you'd like to just skip over to that special piece of information that you're just missing and want to know how to use, you're more than welcome to. So, my name is Andrew, and let's get to it. So, this is the first window that you're going to see when you open up Minitab. As you can see, it's pretty similar to Office products. It has a top bar where your options are located. It has a session window where information is going to appear as you run tests. And it has a worksheet. This worksheet is pretty reminiscent of Excel. As you can see right now, instead of having column names, I'm going to open up Excel right now. Instead of having column names A, B, C, D, E, etc., you have C1, C2, C3, C4, C5, C6, and so on and so forth. The first column right here, which I'm highlighting right now, is going to be the column title. Now, you can type in information here just like you would inside Excel. For example, I can type in dates, and if I type in the date 12-18-18, it will convert it into a date. So you will know that it's a date because Minitab will add a D next to the column name. Now, if instead of that I wanted to have, let's say, numbers, so customers, for example, and I can type in Andrew, Robert, De Niro. So as you can see right now, this turned into a T. That means that it is text. So everything typed in here, Minitab is going to treat it as text. Even if I type in a number, it will show up as text. Now lastly, let's say I have faults or issues, and I start typing in numbers. Okay, Minitab is not going to change the column name because it is a number. So text will show up with a T, dates will show up with a D, and numbers won't have anything next to the column name. You can also highlight the cells like you would on Excel and then click on delete. That's going to delete everything, and the formatting will also disappear. Now, just like with Excel, you can name your worksheet. So as you can see right now, it says worksheet number 1. If I was in Excel right now, I could say sample data. And that way I could name my worksheet. You can do the same thing here with Minitab. Just go over here to the project manager. You will find it on the bottom left. You open it up, and then where it says worksheets, you can do rename with F2, or you can also right click on it and say rename, and then you can type in sample data. And that way your worksheet will now be called sample data. As you create additional worksheets, which you can do by clicking on File, New, and selecting Worksheet, it's the same functionality as you would have with Excel. So if I typed in a new column, Sample Sheet 2, I could do the same thing right now. I could rename this worksheet, opening up my project manager, going over to worksheet number 2, right-clicking, clicking on Rename, and typing in Sample Sheet 2. That's going to show up right here. That way I can tell if I'm working on sample data or if I'm working on sample sheet, because otherwise that's the only difference between worksheet and the other. This whole file right here is called a Minitab project. So Minitab projects contain worksheets, just like you would have an Excel file containing different worksheets right here. So you can click on File, Save Project As, and you can type in a name, for example, Minitab Module 4. You can save it. Now you can copy and paste information from Excel over to your Minitab worksheet. In order to do that, just go over to Excel, copy the data that you want. I'm going to copy this right now and paste it over. If your data has a title, for example, right now I stated supplier 1, supplier 2, and supplier 3 for each of these columns, paste that on the first section. So this is going to be the title of my data, and my data is going to be contained right here. If, on the other hand, I paste it below it, the Minitab is going to treat this as text because it says supplier 1 and it is looking at supplier 1 and it thinks that it's a text value. So everything else is also treated as text. So paste that on the first column. So just like with Excel, you can add formulas over to your columns. So for example, right here, I could type in sum and then say the sum of the following values. And that way I could get the sum of these three values right here. If I wanted to do that on Minitab, I can type in sum and then I can say select your column, right click it, and then click on formulas, assign formula to column, and then say this is equal to supplier 1 plus supplier 2 plus supplier 3. And you click on OK. Minitab is going to add a green cross over to the column title. That way you will know that the formula is creating the following value, and you can't actually, if you try and type on the information, you won't be able to. If you try and click on delete, you won't be able to. If you want to delete everything, then you need to select the whole column and delete it at once. In Excel, you can change the column width in order to make your data fit. You can do the same thing right here with Minitab. You can increase or decrease the column width depending on your preference. So now we can start analyzing our data. If you look on the top row, you will find your most used options. They are going to be File, in order to open up a new project, save your project, or close it. Stat, in order to run your statistical testing. And Graph, where all your graphs are going to be located. Now, we're going to be running our first few basic tests. They are located within Basic Statistics and Display Statistics. So if you click on that option, you will find a menu. Most Minitab menus will look like this. You will find on the left section the columns that have data that you typed in. So note how I have C1, C2, C3, and C4. And I also have the titles that I typed in next to the name. And I'm not showing C5, C6, C7, C8 because those ones are empty right now. Now I can double click on them, or I can highlight them and click on select in order to add them. Now if I add them, then I can then click on OK and run the test. But most Minitab menus will allow you to do different things depending on the test that you're doing. So for example, right now we're displaying descriptive statistics. So if I click on statistics, it will show me a list of options that I have currently. So I can click and unclick each of these statistical options based on the information that I want. So then I can click on OK, and then I can click on OK again. So Minitab has run the analysis for me, and it's outputted the information over to the session window. If instead of having the information on the session window, I wanted to have it within the worksheet itself, so I could copy and paste it over to Excel, what I can do is use the option for Store Statistics instead of Display. So if I click on Store and do the exact same process, and I click on OK, Minitab is going to store the information over to the worksheet. Now note how I only got 2 results. That's because on the statistical section, each menu is different from the other test. So since Store Statistics only has the following 2 options selected, that's the information that Minitab gives me. If I click on More Options and rerun the test, then I will have additional information. Now observe how the column can't have the same name. So even though it's the same information from the same mean of supplier 1, it's now called mean number 2 because the columns can't be the same name amongst themselves. One of the most basic tests that you can do using Minitab is called a hypothesis test, where you're testing if a certain condition is met. So in order to do that, you click on Stat, Basic Statistics, and you have 1 sample T and 2 sample T tests. So for example, I can say I want to run a test, 1 sample T, and my data is located in the column supplier 1. So I want to know if the information from supplier 1, the mean, is greater than 11, for example. So I can do a hypothesis test and can say, what is the mean that I'm searching for? And I can say 11. So then I can click on the Options tab, and the alternative from 11 is that it is not equal to 11. So if my mean is not 11, Minitab is going to let me know. Now when I click on Graphs, I can also create a graph for my data. Now this is based on the test that I'm running. So not all graphs will be available based on the test that you're running. So for example, if I leave this blank, no graphs will appear. Then if I click on OK, my test is going to appear right here. So Minitab is testing the information that I gave it, and most of the time your hypothesis tests are going to go 1 or 2 ways. either the null hypothesis is accepted or the null hypothesis is rejected. So in order for the null hypothesis to be accepted, your p-value, which is used by Minitab, needs to be greater than 0.05. If your p-value is less than 0.05, then the null hypothesis is rejected. And in that case, you would accept the fact that the means are not equal. So right now, for example, Minitab is telling me that my mean is not equal to 11 from this sample size. And that makes sense because if I go back over to my statistics that I stored, I can see that the supplier 1 has a process mean of 10.083, which is not equal to 11. If I rerun this test and said, is the process mean equal to 10.08 and then rerun the test, I would have a p-value of around 0.97, which means that Minitab is highly confident that my mean does equal 10.080. The next basic test that you can run on Minitab is called a two-sample t. That's in stat basic statistics and two-sample t. A two-sample t test checks if the mean of two different samples is the same. So if I want to compare the results from supplier 1 and supplier 2 and say, are the results similar? I can say, okay, is my data in one column? Well, it's not because I have one column for one supplier and another column for the next supplier. So I can say samples in different columns. The first sample is going to be supplier 1 and the second sample is going to be supplier number 2. And then I can also say graphs and I can create a graph. So if I wanted a box plot of my data, I can type it in here and then click on OK. And then here on options, I can once again view what the hypothesis is. So the hypothesis right now is that they're not equal amongst themselves. I can also say, is the mean of supplier 1 less than the mean of supplier 2? Or is the mean of supplier 1 greater than the mean of supplier 2? But for simplicity's sake, I'm going to keep it as not equal. Then we're going to click on OK, and then we can click on OK. Now observe how since I had the graph option selected for a box plot has appeared right now, and I can see my results for supplier 1, and I can see the results for supplier 2. Now if I go back over to Minitab, I can see that Minitab has executed a two-sample t-test between supplier 1 and supplier 2, and it is now telling me that supplier 1 has a mean of around 10.08 and supplier 2 has a mean of around 8.30. So that means that once again I can look at my p-value and my p-value is less than 0.05, which means that Minitab is highly confident that the means of supplier 1 and supplier 2 are not the same. Another must-known option from Minitab is called a normality test. That is in stat, basic statistics, and normality test. A normality test lets you know if your data follows a normal distribution. This is pretty important for most of the tests that you do. So when you do a test, you need to know if your data is normal or not normal and adjust your tasting based on that result. So in order to do that, you get this menu right here and then you say, I want to do a normality test for supplier 1. So you select that one and you can keep everything else as is. You can then click on OK and a graph will appear. Now observe your graph. If your data is normal, it will tend to follow this blue line. If your data is not normal, then it won't follow the blue line and it will have a U-shaped, or it might look like a few stairs going up. As you can see right now, most of the red data points fall within the blue line, so you can assume that your data is normal. Now once again, like with the hypothesis test, you can look at your p-value, and if your p-value is greater than 0.05, then your data is normal. If your p-value is less than 0.05, then your data is not normal. Now here my p-value is 0.43, so I can be completely confident that my data is normal. So the next basic test that you need to know how to execute is called a proportions test. Now the data testing that we've done previously has involved numbers, and the numbers right now fall within a continuing scale. So I have 9, 10, 9, 7, 8. All of this are called variables. There's something else called in statistics called attributes, and attributes can only be one or two things, either pass or fail. So for example, if I have a defective engine, then my engine can either be good or bad. So in order for you to run a proportions test, so when you have data that can be either one or the other, then you do what's called a proportions test. So let's say I did a manufacturing run, and then after a manufacturing run, I ran a test on the engines that I manufactured. And let's say a 0 represents a good engine, and a 1 represents a bad engine that had a failure mode. So let's say from 10 engines, I had 2 bad engines. Okay? And then let's say I did a second manufacturing run, and during that second manufacturing run, I had 3 defective engines. Okay? So since I only did 10 runs, this is pretty simple. I could just say, oh, well, I had 2 engine failures, so that is 20% defect rate. And on the next one, I can say I had 3 engine failures, so that is a 30% defect rate. Well, Minitab allows us to do the same analysis. You click on Stat, Basic Statistics, and then 1 Proportions. And then it says, where's your data? I can say defective engines run 1, and then I can click on OK. And Minitab is going to tell me, okay, event equal 1, which means defect equals the number 1. And then it says, I found, you have 10 data points, I found 2 issues. So that means that you have a 0.20% defect rate, so 20% of your data will be defective. And it also executes what's called a confidence interval. So since this is just a sample run, and you only have 10 samples, Minitab is saying, if you continue to run your process as is, most likely you will have either a 2.5% defect rate, or you will run up to a 55% defect rate. If I had more samples, so let's say I had a longer run, okay, and I had run this test, my confidence interval would shrink because I would have more data points. As I get more data points, Minitab feels more confident in its result. Now, I'm going to leave the data with only the 10 original data points, so I have 10 data points for run 1 and 10 data points for run 2. Let's say I wanted to compare run number 1 against run number 2 and determine if the percent effective is the same between both runs. So I can click on Stat, Basic Statistics, and then instead of 1 proportion, use 2 proportions. Once I click on that, I can say samples are in different columns, and then the first column is defective engines run 1, and the next one is defective engines run 2. I can also click on the Options tab and see once again what my hypothesis is, which is that they are not equal. I can click on OK and then click on OK. Now, as you can see right here, Minitab has calculated that 2 defects were observed on run 1 and 3 defects were observed on run 2. So that gives me a 20% defect rate for run 1 and a 30% defect rate for run number 2. Then Minitab executes the test. Remember, since the following are just samples and I only have 10 data points, Minitab creates a confidence interval. So it compares the confidence interval of run 1 against the confidence interval of run 2. And in that way, it is able to determine if it expects the defect rate to be the same between both. As you can see right now, my p-value is greater than 0.05, which means that Minitab, even though I'm looking at it and one has 20% defect rate and the other one has 30% defect rate, since the sample size is so small, Minitab is concluding that most likely the defect rate is the same between both populations. So there shouldn't be a significant process difference between one and the other. So another very useful tool within Minitab is called regression testing. So that one is located within Stat, Regression, and then Fitted Line Plot. Now, a regression test allows you to know how one factor influences the other. So let's say I have a shop, and inside my shop, customers come in and they purchase merchandise. So one day, let's say I had 0 customers, so at the end of the day, I had $0 in sales. And then I had 2 customers, and then I had $8 in sales, and then I had 8 customers, then I had $128 in sales, and so on and so forth. So, what is my response? Well, my response is the sales that I'm getting at the end of the day. And what do I think is driving my sales? Well, my customers. So I can add my customers as my predictor. I will have 3 options: a linear model, a quadratic model, and a cubic model. Now, if I select the linear model and click on OK, a graph will appear right here, creating a statistical model based on the data that I provided Minitab. So the red data points represent each of the individual values. So when I had 0 customers, I had $0 in sales. And when I had 2 customers, I had $8 in sales, and so on and so forth. Now, the blue line represents where the model thinks the data should fall. So as you can see right now, the model is not really adequate to the data points that I'm getting right here. And the model that I'm getting is located here on the top. So Minitab thinks that sales will depend on minus 1,577 plus 179.4 times the amount of customers that I have. Now, there's a statistical value that is really important called the R-square value. So the R-square value allows you to know how adequate your model is to your data. Ideally, you want to have R-square values that are above 80%. So right now I have a 93% value, so that means that this line right here, while the red data points are not following it, it is an approximation of where do I think my sales will land. Now, if I rerun my test, I can either click on Stat, Regression, and then do Fitted Line Plot, or I can just click on Control E and rerun the same test again. I can change it from a linear model over to a quadratic model, and then click on OK. And I can see right here how my blue line has shifted. It is no longer linear in nature, it is now a quadratic model. And I can see how the red dots fall perfectly within the blue line. So I now know that my sales at the end of the day depends on my customers times 2 elevated to the 2. So customers times 2 will let me know how much I have in sales. Now my R-square value is a lot greater than my previous line plot, which only had 93. This one is 100%. So this one is perfectly adequate to the model that I'm looking at right now. I can also rerun this test over for a cubic model, and then click on OK. And I will have a different model than I had previously right here. But note how they are practically the same model, only that this has added a cubic element, but since it's times 0, well, it doesn't affect anything. So you can usually run your test using a linear, a quadratic, or a cubic distribution and pick the one that has the best R-square value for your needs. Like we showed previously, you can compare samples amongst themselves, for example, supplier 1 against supplier 2, using stat, basic statistics, and 2-sample t. Now, if you wanted to compare multiple sample means amongst themselves, for example, suppliers 1, 2, and 3, you would do a stat, ANOVA, one-way unstacked, and then you would type in the information. So you would select supplier 1, supplier 2, and supplier 3. And then, for example, you can click on Graphs, and you can ask Minitab to create your graph. So you can select the option of 3 and 1 and BoxPlot data, and then you can run it. And now Minitab has created the following graphs based on the information that you requested. So if we look at the BoxPlot, we can immediately see that supplier 1 tends to be in the middle, supplier 2 tends to have worst values, and supplier 3 tends to have the highest values. Now, if you go over to your session window, you will find the results of your test. So right here, it is telling you that supplier 1 has around 100 data points located on the column, and the process mean is around 10.08 with a standard deviation of 0.89. Supplier 2 has also 100 data points, and then it has a mean of around 8.30, and supplier 3 has 100 data points and a mean of around 12.038. Now, Minitab has created this analysis for us, and it is also creating a handy graph. So this handy graph is showing me that supplier 2 has a mean of around 8.4, which is the same data that I'm having right here. And then supplier 1 has a mean of around 10.08, which I'm showing right here and also on this graph. And supplier 3 has a mean of around 12.038. And as you can see right now, none of this overlap. So I can conclude that the process mean is not the same amongst themselves. So one of the most powerful tools that Minitab has at your disposal is called a DOE, a design of experiments. In order to do that, you click on Stat, DOE, Factorial, Create Factorial Design. So right now you will have your window, and you can leave this option as is. You can type in how many factors you want for your test. For now, we're going to select 2. Then you click on Designs. Now, if you have the option to do a split factorial, the option will appear right here. For now, we're going to be going with a full factorial. And then how many center points you want per block, replicates for each corner point, and number of blocks, you can modify this as you want. For now, we're going to leave it as is. We're going to click on OK. And the following 3 options have now appeared. So I can click on Factors, and I can type in the factor names. I'm going to click on OK. Now, you can leave everything else as is, or you can go ahead and go into Options and unselect the option for randomized runs if you want to do this faster, or you can leave it checked, and then you can click on OK. Minitab is going to create a new worksheet for you. The only thing you need to do is add a results column, and then you can run each of the following setups that Minitab is showing you right now. So for example, now we can analyze our DOE results using stat DOE factorial and then analyze factorial design. You can add the results column as a response and then click on OK. And then you can click on stat DOE factorial and then response optimizer. Then you can add your results column and then click on setup and say, what do you want to do? So let's say I want to optimize my result so that I hit a lower spec of 240, a target of 260, and an upper spec of 280. So then I can click on OK and then run this test. So Minitab is going to recommend the following setup for me in order to hit my result. So it is telling me release at 155 and put your pin at 143, and you should be hitting close to your mark. So here, over to the left or toward the right. Now observe what happens here on my Y. My Y is my distance traveled. So as you can see right now, as I go lower and lower, my distance traveled decreases. So if instead of releasing at 155, I released at 149, I should be landing at around 240. Is your process. So you can move either up or down, or you can use the stat DOE factorial response optimizer setup and then select what values you're targeting. Now, this blue line right here represents where you're landing, and the white area represents the process window that you requested. So if I leave the process window, then I will no longer be landing between 240 and 280. I'll be landing at around 306. In order to control your process, Minitab allows you to create something called control charts. In order to do that, you click on Stat, Control Charts, and then Variable Charts for Subgroups or Variable Charts for Individuals. If you're taking multiple samples per time, so for example, let's say I have a manufacturing process and I take 2 samples each hour, that's called a subgroup. That means that I take a subgroup size 2, so 2 samples per hour. If instead of doing this, I only took 1 sample at a time, that will be a subgroup size 1. So I would use a control chart for individuals. Since right now I'm using 2 samples at a time, I would use a subgroup of 2. So I would do an X bar R, and then I might tell me where is your data located. I will tell it it's located in C10 part height. And what is the subgroup size? I can either type in the number 2, or I can just say look at the time column. So Minitab is going to look at the time column, and if the following data points are the same, it's going to say, oh, so you took 2 samples at 1, you took 2 samples at 2 o'clock, 3 o'clock, 4 o'clock. Then you can click where it says scale, and then you can change from index over to stamp. If you do this, the Minitab is going to take the timestamp and put this on your X column. So if you click on OK, observe how my time is now located on this bottom right here. If I had run the test, which I'm going to do right now, instead of doing this timestamp, I had done index and run this test, the Minitab would just show me sample 1, sample 2, sample 3, sample 4, and would disregard the value of my data, which is on the timestamp. Now, how do you interpret this? Well, based on the data that you provided, Minitab allows you to know if your data is within control or not. So data points that are above or below the control limits located on the red lines will be flagged with red dots. Now, you can also ask Minitab to route additional testing for you. So if you do stat, control charts, variable charts for subgroups, X bar R, and then X bar R options, and you go over to tests, you can select which points are important for you. So one of the basic points is 1 point more than 3 standard deviations from the center line. So any data point that is above or below the lower control limits will be flagged with red. You can also add X amount of points on the same center line, and you can select how many points are considered adequate for you. So you can type that in right here. Now, your X bar has 2 parts. One is the mean and one is the sample range, but we're not going to get too much into detail, okay? If you have any questions, feel free to watch my additional videos. If instead of having a subgroup size, you had taken only 1 sample at a time, you would click on Stat, Control Charts, Variable Charts for Individuals, and IMR. Then where are your variables located? Once again, it's part height, and you would simply run your test. So Minitab is going to tell you, okay, your observations, 1, 2, 3, 4, 5, 6, they would no longer be grouped. So if you compare this chart over to your X bar chart, observe how your X bar has grouped the data points. You had in total 8 data points, but only 4 individual categories. So that is why you have 4 data points. while on the other hand, the IMR chart takes every single data point into account, and that is why you have 8 data points in total. Now, the XBAR and IMR charts work for variables, so that means data points that are on a continuing scale. Let's say you actually wanted to monitor defects. So we're going to be going back over to our worksheet that has the sample data, and as you remember, we had defective engines run number 1. So we had 10 data points, and we had defective engines marked with a number 1 and good engines marked with a number 0. In order to analyze this, we do what's called a P chart. So that is in stat, control charts, and then attribute charts. There's a chart called a P chart, so select that one, and then it's going to tell you, okay, where are the variables located? Just say defective engines run 1. What is the subgroup size? Let's say it's a number 1. We only took one sample at a time, and then we click on OK. Now observe what has happened. So Minitab has created this chart showing us how our issues have appeared. So all of a sudden in sample number 2 I had an issue, I had a defective part, and sample 3 over to 8 had no issues, sample 9 didn't have an issue, and then all of a sudden sample 10 had an issue. So this is useful for you if you're monitoring your process with a timestamp. So you can say at 2 o'clock or at 3 o'clock or at 4 o'clock we had a quality defect, and you can do it the same way. You would click on scale, stamp, and you would select the column that had the timestamp. So let's say you added a comments column over to your monitoring chart. This way operators and employees could add comments based on the issues that they had at 1 o'clock, 2 o'clock, 3 o'clock, and 4 o'clock. So in order to analyze this data, we do what's called a Pareto analysis. You click on Stat, Quality Tools, Pareto Chart. And it's going to ask you, where is the defect data located at? We just tell it in C11, Comments, and then click on OK. And Minitab is going to execute a Pareto analysis. A Pareto analysis is a very simple analysis called the 80-20. Where it's telling us that at least 80% of the defects are caused by around 20% of the possible categories. So as you can see right here, most of my defects are related to temperature issues and high oil levels. They're not related to calibration issues, and they're not related to tooling wear. So this is a quick and easy way to know where your efforts need to be advocated in order to resolve your most common root cause. So the next quality tool that we're going to talk about is called the cause and effect analysis, also called the FishBone diagram, and also called the Ishikawa diagram. So let's say I'm trying to do a root cause analysis for my temperature issues. So I can do a brainstorming session with multiple engineers and ask each of them what they think could be influencing my result from the personnel side, from the machine, the materials, the environment, measurements, and methods. In order to analyze this, I would just click on Stat, Quality Tools, Cause and Effect, and then it would tell me, okay, where's your personal information located at? I would just tell it in C13. Where is your machines section located at? I would just say C14. Where is the materials information located at? C15. Methods, I can say C18. Measurements, C17, and the environment, C16. What is the effect? I can say temperature issues. I can also type in a title, root cause analysis 0015, for example, and then I can click on OK. Minitab is going to create an automatic fishbone diagram for me. I'm not going to get too into detail, but the point is that the diagram is created automatically for me. So we've been talking about analyzing normal data. Let's say you're running a normality test on some samples that you took. So we're going to do normality test for our non-normal samples. And then we get a p-value that is below 0.05, so we can conclude that our data is not normal. In that case, what do we do? Well, if we want to continue analyzing our data, we need to find out what distribution it follows. So in order to do that, we click on Stat, Quality Tools, Individual Distribution Identification, and it's going to tell us, okay, where's your data arranged at? I'm going to say non-normal samples. And how many samples you took each time you monitor your process. Let's say I only took one sample at a time. And we're going to select the option that says Use All Distributions and Transformations. Once we click on OK, Minitab is going to create 4 graphs for us, which we can ignore. And we can look at the session window. When we look at the session window, we'll find a goodness of fit test. And what we're looking for is the distribution that has the highest p-value without taking into account the transformations. So let's look at our p-values. The log normal has a p-value of 0.26, which is pretty good. The Weeble has a less than 0.10, so that is really bad. I can also look at the 3-parameter weevil, which is at 0.24. And if I go around, I can see that the largest extreme value also has greater than 0.25. But let's see. And lastly, we have a transformation value, but once again, we're not going to take into account the transformation values. So the highest one seems to be the log normal. So we're going to be looking into that one. And in order to do this, we go down here to where it says estimates of distribution parameters, and where it says log normal, we're going to look for it, and it says log normal. And it says using the following parameters, which is a location value of 3.99 and a scale parameter of 0.17, you should get a pretty good approximation of the data that you have on this column. So that is how you determine the distribution of your data based on Minitab. In order to run a capability analysis, you need to go to Stat, Quality Tools, Capability Analysis, and select either between normal or non-normal. On our previous example, we were looking at the non-normal samples located here, and we had determined that they followed a log normal distribution. So we're going to click on Stat, Quality Tools, Capability Analysis, and Non-Normal. We're going to select our non-normal samples column, and then we're going to tell it to fit the following distribution. So we're going to select the log normal one. We're going to add the lower spec of our process and the upper spec of our process. For example, we're going to use 30 as our lower spec and 90 as our upper spec. And we're going to run this test. Minitab is going to create the capability analysis. For non-normal data, it's only going to give us the PPK value. So the PPK value is the overall process capability of our analysis. So as you can see, it has a PPK value of 0.96. It will also show us how many parts Minitab expects to be out of spec for the lower spec at around 389 samples. How many samples will be out of spec in the upper range, which is around 1,896 samples, and how many parts per million opportunities it expects to be out of spec, so around 2,285 defects for every million parts created. Now note that this analysis was made using non-normal data. If we had analyzed the information using the normal data and used the same column, same subgroup size, and same lower and upper specs, we would have gotten a completely different result. So that is because if we tell Minitab that our data is normal and analyze it using a normal distribution, our PPK value is going to suffer. As you can see, it says 0.84, while before I had 0.96. The next test is a Gage R&R study. A Gage R&R study is known as a measurement system analysis, which allows you to know how capable your measurement system is. So in order to do that, you go to Stat, Quality Tools, and then Gage Study. Then you go to Create Gage R&R Study Worksheet. So you click on that one. And it's going to create this little menu where you can say how many parts are in your Gage R&R study, how many operators you have, and how many replicates you're going to have. So let's say you have 5 parts, and each part is measured twice, and you have 3 different operators. You can also type in the names of the parts. So this can be part 1, and this can be part 2. Once you have this, you can click on Options, and you can either select Randomize Runs or Do Not Randomize. You can click on OK, and then click on OK. Now, Minitab is going to create the worksheet for you. You just need to type in a results column. And now you can just type in the results that each operator got. So we're going to do that right now. Once you have your results, you can analyze them using Minitab by clicking on Stat, Quality Tools, Gage Study, and then you can select either crossed if this is a crossed Gage R&R study, or you can select nested if it is a destructive based Gage R&R study. After you click on crossed, it will ask you for the part numbers, so just give it the parts column. And then what is the operator's name? So just give it the operator's result. And what is the measurement data? So just click on results. And then you can also, on the options tab, add the lower spec and the upper spec. So I'm going to be adding the lower spec right now and the upper spec. You can also add a title as well. You can click on OK and then click on OK. Minitab is going to run your Gage R&R study, and it's going to create 6 different graphs based on the variation presented by the Gage R&R study, the repeatability, and the reproducibility. It's also going to show you on your session window your statistical results, so you can scroll up And you can see right now it says how many parts were measured, how many replicates, how many operators, and how many total runs you had. And it's also going to tell you what is the total Gage R&R contribution, and it will also tell you what is the study variation from your repeatability and reproducibility. So these two added together will give you a total Gage R&R study variation. It will also give you the number of distinct categories. And usually when you're doing analysis, you will have a corporate guideline document telling you how much study variation is accepted and what is the number of distinct categories that you need minimum. It is usually recommended you have at least 5 distinct categories and a percentage study variation that is less than 30%. So this will be considered adequate for analysis. Now, Gage R&R studies are done for variables. So as you can see, I have numbers right now. If we wanted to do an analysis for attribute data, we would need to do what's called a Kappa test. You can execute that using Minitab by clicking on Stat, Quality Tools, and then Attribute Agreement Analysis. So first you click on Create Attribute Agreement Analysis Worksheet, and it's going to tell you, okay, how many samples are going to be analyzed. So let's say we're analyzing 10 samples. How many appraisers you have, so how many operators are doing the analysis, and how many times they're going to do the samples, so how many replicates we're going to have. You can also click on Options and deselect the option for Randomized Run, so you can select Do Not Randomize, click on OK, and then click on OK. So Minitab is going to create the worksheet for us, so we just need to add a results column and the expert or standard column. The expert or standard column will contain the actual results. So for example, if my part 1 is a good part, then the expert should say good. And if my part 2 is a bad part, it should say bad. On the results column, I'm going to type in the individual values. So if I give part 1 over to Andrew, does Andrew think that part 1 is a good part? So let's say he says it's a good part. And then I give part 1 to Robert. Does he think that's a good part or a bad part? Let's say he says bad. And I go along and I just repeat it. So I give each operator the part that Minitab is telling me, and I type in the results on the results column, and I also type in the result from the expert. Remember that the expert can't be wrong, so the expert must agree at all times with himself. Once you have all your results, you can analyze them using Stat, Quality Tools, and then Attribute Agreement Analysis. You click on that, it's going to tell you, okay, where are the results located at? We're going to click on the results column. It's going to say, where are the samples located at? So we're going to click on samples. And then it's going to tell us, okay, and who were the operators or appraisers? So we're going to select column number 3. And then it will also tell us as an optional value, do you know what is the standard or attribute? So that will be the expert result. So we click on that one. And then we click on OK. Minitab is going to execute the analysis for us, and it's going to give us a few graphs telling us how each appraiser did. So as you can see, the blue dot represents their Kappa value. So I can look right now, and the appraiser versus the standard, everyone right now seems to have gotten a 90% appraisal rate. So I can look at this right now, and this will be considered my Kappa statistics. Usually it is recommended in the industry for an acceptable Kappa test for people to have a value greater than 80%. So that means that 80% of the time they analyze a good part from a bad part. You can also look at the result right now where it says all appraisers versus standard, and you can look how many samples were inspected, how many were matched, and what percent in total everyone got. You can also look at it individually, so you can go up and you can look each appraiser versus standard, and you can look at Andrew, Robert, and Ricky, and you can see their Kappa percent result. So they have their 90% over here, and this is the result that we will put on your analysis. Now we're going to be looking, we already finished through the stat column, so we're going to start looking at the graphs. So in order to do that, we're going to go over to our worksheets. So you can click on this option right now. It says show worksheets folder. We're going to go back over to the sample data folder. And what we're going to do is, first of all, we're going to create a histogram. So we do that by clicking on graph, histogram, and then we'll have 4 options. We can select the simple one, click on OK. And then it will tell you what do you want to graph. So you can either select one by one, and you can run this analysis right now, and you will have your histograms right here. The histogram is simple, it's easy to understand. Now let's say you wanted to do a box plot. You would do the same process. You would click on graph, and then you would go over to box plot. You can select either a simple one or one that has multiple values. So we're going to use a simple one right now. We're going to click on OK, and then we will select 3 suppliers, select them, and then click on OK. And we'll have 3 different box plots for each one. Let's say I wanted to have all 3 suppliers on the same graph. In that case, I would just click on graph, box plot, and then click on multiple Y's. So I click on multiple Y's, and then I will select my suppliers, then click on OK. And this is going to create all the suppliers on one same graph. Lastly, if you wanted to do a different type of chart, which would be a bar chart, you can, for example, let's say our defective sentence run, I can click on graph, bar chart, and then I can say how many counts of unique values you have. So let's say I wanted to know how many zeros and ones I had on this column, so I can select on the simple one, click on OK, and it will tell me, okay, I'm gonna count the values on column 6, which is this one right here, then click on OK, and it's showing me that I have 8 values with an equal zeros value, and then I have 1 value that equals 2 values that equal 1. Okay, I can also add reference lines if I like by right-clicking on this, then clicking on Add Reference Lines, and I can add a reference line on the Y value, for example, add 2, and I could add another one by clicking on space and then typing in a number 8. So it's going to add 2 reference lines. If I wanted to change the color for some reason, I can just double click on the line itself, then go over to custom, change the type of line that I have as well as the color, and I could even change the size, so that's going to give a different format. I can also change the color of the bars themselves by clicking on custom on the fill pattern and then selecting a background color. Let's say I want it to be blue, so I click on OK, and now my graphs are blue. The last basic graph that you need to know how to execute is called a pie chart. You can do pie charts on Excel, so you can also do them on Minitab by clicking on graph, pie chart, and then it will tell you, okay, what values do you want me to add to the pie chart? So you can select the defective engines, run 1, and then just click on OK, and now you'll have a pie chart. So that was everything you need to know about how to use Minitab effectively in 50 minutes or less, just in time for that brand new job presented by Kusum. My name is Andrew. It's been a pleasure having you. Please feel free to leave us a like, a comment, or subscribe to our YouTube channel. We're going to be branching out to additional modules. We're going to be talking about financial analysis, and we're also going to be talking about Excel, as well as other tools that engineers use. So thank you very much for your time. I hope you have a wonderful day. Bye-bye.